What's going on, you guys? Mr. Allen here. We are about to write an exponential function with an exponent of just n rather than n minus 1 given the geometric sequence. All right, so I have a sub n equals 3 times 7 raised to the n minus 1, and I just want n here. We're going to bring in some exponent properties to help us out with this one. So we want to have an exponential function. We'll call it g of n. So g of n equals, and then we're going to have 3 times, I can split this up. I know for exponential properties, or exponent properties, excuse me, when I'm multiplying like bases, I add the exponents. So I could split this up. I know I said add the exponents, but it's going to be just like adding a negative 1. So we're going to have 7 to the n times 7 to the negative 1. All right. Now, little mathematical sidebar down here. If I had x to the third times x to the fourth, I would add those exponents, right? Or if I had x to the third and x to the negative fourth, kind of looks like it, I'd have x to the 3 plus negative 4, so 3 minus 4. Kind of like what we have here with the n minus 1. Hopefully that helps. All right, we'll see. So now I'm going to rearrange some things, okay? So I have g of n equals, now 7 to the negative first. If I have a negative exponent, like we have here, I could move this to the denominator and make it positive. Ooh. All right. So I'm going to have 3 over 7 times 7 to the n. So I move this 7 to the negative first. Underneath that 3 right there is my denominator, and now I have 3/7 out front. If that was too much for you too fast, we could have written it like this: 3 times 7 to the n over 7, and then I'll group these two as my fraction out front, right? So this here becomes like my coefficient out front there, which will then be a vertical compression by 3 over 7. So there we have it. We have an exponent of n, right? That's all it really asked for. We're good to go. Let's do it. Let's do it. We got one more. Let's do another. Let's do another. All right. Same kind of idea here, right? So I'm going to rewrite this as g of n equals, we got 6.2 times, we have 10 to the n, and then my like base, again, 10 can be to the negative 1. And this could work if it was like n plus 3. It would just be a 3 and an n and a positive 3, right? Okay, but you're not going to really see it written that way with like geometric sequences in series. So let's continue. Well, now this 10 to the negative 1, I'll write it out with a few steps this time, just in case the last time was like, whoa, bro. We got 6.2 times 10 to the n over, because this guy can go to my denominator now and becomes 10 to the positive first, right? It switches from negative 1 to positive 1. Now I'm going to group these two here together, and I'm going to have g of n equals 6.2 divided by 10. Couldn't I just move my decimal one place? So I could do this, 0.62 times 10 to the n, right? I can move that decimal place back 1 because I'm dividing by 10. Ooh, that's a clean look to it rather than as a 6.2 over 10. Nobody wants decimals inside of fractions. That's just like a no-no for whatever reason. I don't know why, but it is, all right? So there we go. Got two different examples. One where we got into a decimal form, one where we left it as a fraction. That's dope. That's awesome. See you dogs later.